Jai Hind everyone. In the previous lecture we have studied about the fiber optical communication and the basic about the fiber optical communication. Now today my third lecture will be on the digital transmission rates of telephone systems. Now we are talking about how the digital transmission rates of a telephone system can be work perfectly or effectively. So that is the efficiency which can be defined. These are the rates where the signal can be effectively and efficiently used to share the information from one side to the other sides. So here I am talking about number of voice channels which I use to transfer the information. Now we are talking about the transmission designation, how we can be used to transfer with the help of what kind of a mechanism, what kind of a method I am using for the transmission of that data. Now we are using a signaling designation, what kind of a signal we can use for the transmission of data, and at last data rate. What data rate I can use to transfer the information. That is one of the most important part of the communication, because whenever you send any data, whenever you send any information from source to destination, that is important to know how the bit rate you can travel from one side to the other side, and how much efficient and how much perfectly the data is to be sending with that particular sources to destination. So these are the number of channels. I am talking about number of voice channel 1. If we are using a one channel, then transmission designation is not available, signal designation is not available, and data rate is 64 kbps. This is a basic data for a transmission, which is used for a simplest form of a data, 0 1 data. It may be digital, it may be binary, whatever you want to send. So this is the basic first part of the signal transmission used for voice signal channel transmission. Now 25 number of voice channels we can be used for the transmission of data. At that time we use a T1 transmission design, and the signaling designation is DS1, data signal process 1, we can be represent on that part, and the data rate for the transmission of that time you can see at here. 1.544 Mbps. First data rate 64 kbps, but right now presently the data rate is 1.5444 Mbps. Means 1000 times improve the data as comparison to the kbps we going to be megabits. So this is the beauty of the optical communication. We can use a larger amount of data transmission with the help of this thing. So now we are talking about second 48 2 TTI system. It means we use a T1 system where 24 signals will be including or utilized on that simultaneous transmission of that data. Now that will use a T1C transmission, and the signaling processing use a DS1C, the part of that one, and now the bit rate is almost double on that case. If you look at the data rate 3.152 Mbps, it means twice. If we are using 1.5, so right now we use a 3.1. It means twice the data we can be signaling and transferring from the one sources of with the rate of a data, and signaling designation used on the DS1C. Now come to the next part of that. We can almost double it here. 96 for T1 system we can introduce on that part, and at that time we can use channel transmission designation is T2, and the data transmission signal is DS2, and the bit rate is almost again the double, twice. We can say twice the signals we can see from the previous one. So that is the beauty of a communication. If the data is traveling, if data is to be sharing, if information is sharing from the one side to other side, so you just understand how effectively and how perfectly data will be shared with that thing. So this is the basic procedure of a telephone system for the transmission of data. We use a multiple signal designation, we use a multiple voice channel, we use a multiple transmission designation, we use a signal designation is different and data rate is different. Now I am talking about today's scenario. The 8064 12 3G systems will be introduced, and the transmission designation is undefined, and it will be simultaneously traveling the information continuously from the one side to the other side without any recurring, without any noise, without any disturbances. The data is effectively and efficiently is moving from one side to the other side, and the bit rate, if you look at that, 565 megabits per second. You can imagine this is the basic on 2016 and 2017, but right now 2024, in 2024 we send the data in terms of terabits per second. That is a very huge data amount which can be used for the transmission of data. Presently, the speed of data is 579 terabits. Beyond the imagination, the data will be sent. You just think about just a click press on your mobile, you just click press on your PC, your laptop, any communication device, and data will be transferred from the any country, anywhere throughout the world very effectively and very efficiently. So communication, optical communication is, that's why it is one of the most backbone for the today's scenario. Now we are coming to the next part of this one. If you understand that, now we are talking about some of the networks which can be used to traveling the information or sending the information very effectively and efficiently from the one side to the other side. The network name is SONET. The network name is SONET. SONET stands for synchronous system. You just understand the meaning of a synchronous system means simultaneously synchronize your data from the source and destination together. It is not effectively changing, it is not effectively too disturbed, it is not effectively produce any kind of a noise. It is provides a little bit disturbance and dispersion during the transmission, but still it is one of the most favorable data transmission system used in optical communication right now. We can be used other system also. The name of other system is a MANET. This is also another system which can be used. Mobile ad hoc network system. This is the basic system right now we are going on to be transmitting the information with the help of this one. So now we are talking about the beauty of that system when the synchronous system is simultaneously working. When the synchronous system simultaneously working, you can share data continuously from the one side to the other side without any delay. It means that sending end and the destination and both are club the data and constantly traveling the simultaneously. You just adapt the adaptability of that thing. If the source is sending the information, then the destination is adapting the data without any delay, and simultaneously multiple input and multiple signal is traveling on the same bit bandwidth. Use a multi bits of data, maybe Mbps data we can be sent at any time and with any delay in between that signal transmission. So this is the beauty about the transmission of a signal which can be used in a SONET. Now we can be used for that. This is has been developed a newer transmission standard for worldwide use, because the data is not going to your home. The data is going worldwide. It is going to one city to other city and going to the one area to the other area, and it may be going to one country to other country, and whole country is connected with a network, and that network are connected interconnectedly with a node. So that is the beauty which can be used to travel the information with the help of this new transmission standard for worldwide use. Because with the help of this, synchronize your data with source effectively and efficiently, and that data is constantly running from the one side to the other side. Lots of amount of data you can share at any time, and that time that you think about, the data is never lost during the transmission of source to destination. So this is the beauty about the optical communication. You can use a larger number of bandwidth, you can a larger number of data, you can use a multi-channel data, you can use a larger amount of subscribers simultaneously for the signaling that data and transferring the data simultaneously. Now we are talking about that part is one of the most important part of a SONET. It allows greater flexibility in adding new services to existing SONET installation. When I install some network, if I'm installing some network to servicing of existing network, WDM, DWDM, CWDM, and any other kind of a wavelength division multiplexing, you can introduce in that part. And SONET, synchronous optical network system, is to be collaborate with that data, and during the installation you can utilize the property of this data is also, because this is one of the greatest flexibility, one of the greatest approach of this network which can be accessible by us for transferring the information very effectively and efficiently from that part to the other parts. Now the basic SONET transmission rate is OC1, optical communication 1 is 51.8 Mbps, and the electrical equipment STS is 1, which can be. Why we are talking about the optical communication and why I am talking about the electrical equipment? Because the optical data is also used electrical interference duration of the transmission, because electrical to optical conversion is always required during the transmission. If I am not connecting with the electrical signal, I am not connecting to electrical optical with the help of, in case of OC1, LED is required, laser is required, and many more sources are also required for a transmission. But in case of electrical, these sources will be worked as a photodetector, like a photodetector for the transmission purpose detector, and the same time we can use a PIN also, and lots of other detector can also introduce during the transmission of that thing. So this is a combination of electrical and optical. Before transmission, you just convert electrical signal into optical, and then the receiving end you just go for a optical to electrical, because electrical data is easy to attend and easy to understand the capability or capacity of data transmission used by that mechanisms. Now this is a transmission process, designation and data rate for the transmission used in a SONET. In electrical, we use STS, and this is OC1, and bit rate is 51.84 Mbps. But when we are talking about simultaneously transmission of system 48, the optical communication is 48. We can be used, and the data rates you have seen at here 2488.32 megabits. It means that is approximate the data of approximate 220 times we can be increased from the one data transmission to the fourth one data transmission. So this is the basic propaganda of the transmission used in a SONET, and that is now most widely, most effectively and most efficiently used for the transmission of the signal and sources. I'm not talking about this network. The future is many and many more. We are talking about the future of many more, because this is the basic about the optical communication and basic SONET transmission data which can be assessed by the basic protocols. Now we are talking about the next strategy in optical communication. I'm looking for that. Fiber distribution data interface. It means how the data is to be transferred. Fiber distributed data interface. How data is to be interconnected to each other. How data can be traveled from one side to the other side. How the data will be shared from the one side to the other side. How the fiber is distributed, that data which I send from the source to destination, that is to be defined by the fiber data distributed data interface. Interface means the interconnection between the data that is used for the fibers. Look at that. Source that connected with the fiber, and after that destination. That fiber, how interact with source and how interact with destination, this is known as a interfacing process for the transmission of data. If you're getting that point, it means you just understand we can send any amount of data, we can send any amount of information from one side to the other side without any distortion, because the interface is required most important part in optical communication for the transmission. If I'm not getting that point, it means you never share your information. You are not capable to share your data from one side to the other side effectively and efficiently. So you should require the interface between source and destination with that fiber is important. Now we're talking about the relation. The first thing between the bandwidth and the message time has now established between the common music. How we can interface voice, video, music, text, picture, images, and many other things can introduce on that time. When we can collaborate all those things, which can be used the bandwidth of that time, and what kind of bandwidth used for a voice, different, message, different, picture, different, video, different. All the bandwidths club together and share the data and travel with the help of that. So at that time, the source, destination and interface as required, the data rate, efficiency of the data rate, how perfectly you can share your data, how effectively you can share your data, that is important. If you not understand, if I'm not getting that thing, the data is very effective and very efficient and transfer from one side to other sides, how the data is to be gathered, that is to be using the data interface. At that moment, you are looking at that thing, we can use the communication networks for such things to be transferred. Such transmission required bandwidth that depend on desired rate of information of transfer. I'm talking about the desired transformation of rate. Why? Because if it is accessible, it means you definitely share your data effectively. If you are not sharing your data effectively, it means the data is totally waste and the bandwidth is required by you is totally waste at that moment of a transmission. So you should capable to understand how effectively and how efficiently the data must be shared from the one side to other side and use a perfect bandwidth for the transmission of data. Now we are talking about the second point of that. First I will cover the data transmission. The second, for higher speed data transfer, the fiber distribution Data interface has been specified to operate a data rate of 100 Mbps. Now the data rates are higher, the bandwidth is higher, the amount of the signal is higher, the information of signal is to be higher. At that time, the data rate is also higher for with the help of fiber distribution data interface. Means FDDI is introduced when the data rate is to be high for the transmission signals. It means you just share your data very high amount whenever you're talking about, when you share your data very efficiently, effectively, at that moment you use a FDDI for the fiber data distribution interface effectively and efficiently for the higher data bandwidth is required duration of transmission. Now we are talking about next point of that. Even more faster data is required. Now that is possible. We always try to send information. We just send one message from one side to the other side. So definitely it uses some bit of data, maybe Mbps, maybe is a huge amount of data is traveling or downloading. It will be some Gbps, 1 Gbps, 2 Gbps, 100 Mbps, 500 Mbps. At that time, the data rates is high. If we are talking about greater data transformation, a large amount of file which can be downloaded right now, we use a faster LAN, higher performance parallel interface operated at 800 Mbps. That means approximately 1 Gbps data is to be used for the transmission of a data in 1 second. Are you getting my point? This is a very huge amount of bandwidth is utilized and transferring the data from one side to the other side very efficiently and very effectively without any delay. And nowadays we can transfer a huge amount of data, approximately terabits of data, and very terrifically from the one side to the other side. Such thing is explosively share the information. You just talk right now, you dial any number and directly connect to the US, you directly connect to European country and Asian country, anywhere from the world. The thing is in data rate. If data rate is perfectly used and data rate is perfectly efficiently transferred from one side to the other side, it means you can share a large amount of information without any hesitation. So HPPI is for use a high performance parallel interface for the data transmission without any delay and without any kind of information lagging. You will just share a data. Approximate the speed of data transmission is 800 Mbps. And you can imagine your data will be transferred from one side to the other side fraction of second. Just click your data and that data is definitely on the same time it will be received from the other end. If the data rate is speed, the destination and is also is similarly used for that thing. Now we are talking about one more point. There is study evolution toward higher data transmission rates. A data transfer becomes more important to business and industry. Obviously, if you are talking about the mobile communication, if you are talking about the optical communication, if you are talking about any business, if I am talking about an industry, so definitely they require a huge amount of data transmissions, and they use a higher bit rate of a data transmission without any lag and without any delay. So at that time we use a Gbps, Mbps, Tbps and Pbps. It means we can be use a higher amount of data transmission for the communication purposes in industries, for communication industries as well as business purposes. We use a higher data distributed system for the transmission of information from one side to other side with the help of data interface. So this is one of the most important part for the transmission purposes. If you understand the transmission purposes, it means you can use the things how effectively and how efficiently share your data from one side to the other sides. Are you getting my point? I think this is one of the wonderful slides right now. I'm open at here. This system, the fiber system operating below 100 kbps have low transmission rates. Such system can be readily, cheaply constructed from available optical and electronic components. Means just share a very low amount of data. If you are talking about the data transmission, I'm using means only 10 kbps data. 10 kbps data. And that data, what is this? This is only depend upon networks. 100 kbps, 10, 100, 200, 300. Such kind of data we can be used for the transmission purposes. It means you just use a transmission system. It does not require a very huge setup for the data transmission. No need for the huge amount of data transmission. You just require a basic and smallest network for share your data, for travel your data, or for sending your data. It means you directly share your information from one side, from other side with the help of this available optical and electronic components. In available electrical and optical component, we are talking about this. The same here. We are using a transmitter and using a receiver, and in between use a fiber for the communication. Nothing else you just require for the transmission of a data. You just go for that thing and directly you share your information with the help of transmitting it. Use a source, electrical to optical, going to the fiber, and you can use an optical detector and receive the data, and receiving, and you just share your information. It means source and destination are interconnected to each other, and simultaneously at the same time you can effectively share your information. So this is not a very huge time or huge data is required for a transmission of that. You just share 100 kbps, 200, 300. Cheaply, a simple network, optical network is to be used and connected on that few parts and directly share the data. Now we are talking about rates from 100 to 10 Mbps are only somewhat more costly and difficult to implement. This is moderate range of information rate. Definitely, if I'm talking about some basic structure, that is not a use too much things. It is a maintained very easily and effectively. But when the requirement is higher, when the data bits are required higher, when the amount of data is higher, what should I do at that time? We are talking about higher bit rate. We are talking about this much amount of data, and that time the system is very costly, difficult to implement, and all these things. You are very careful whenever you make a huge amount of data. At that moment of data, you always remember the complexity of the system is to be increased. When the complex system is increased, it means you share your views very high amount of data. So maintenance cost and implementation cost during the high amount of information is very large. So remember the point, when I'm going to the kbps to mbps, so definitely the cost, installation, maintenance, everything is to be increased. That is the priority of the data transmission, and that is the beauty of a transmission of data. Nowadays, we use a terabits amount of data which can be traveled with a fraction of seconds with the help of this several kind of networks. Now it rates going to 10 Mbps to 1000 approximate 7 Gbps. The circuit is improved, light is emitters, light detectors must be used. It means the network is complex, and that time we use a light amount of the system. We use at time the light emitters, light detectors. The system is not heavy on that time during the transmission from one side to other side with the help of several Gbps. So remember the point. Here we implement a different kind of optical network. We used right now the technology used a next generation passive optical network, where we are talking about the data transmitter is a terabits, approximate 500 terabits per second. That network is to be established, and during that establishment, the component is very light. It means the data will be flow very effectively and very efficiently without any lag. So detectors, circuits, and light, everything is to be improved during the transmission of such thing. So this is the beauty of a transmission of that part. Now we are talking about the range above 7 Gbps is very high and require added expense and care. Definitely, if you are going to be higher bit rate of data transmission, definitely the system is using a very high bandwidth, requires a multiple network, and amount of data will be, amount of a system will be introduced onto that part. That time the system is very expensive, and the care is very effective and efficiently. If I'm talking about a single system, only a single user is used at a time, but we use a several amount of more than 100 Gbps data. Larger amount of a capacity is required to maintain the data bit rate and maintain the system on that time duration of a transmission of that part. So that thing is important. When the bandwidth is enhanced day by day, so this thing is also enhanced during the transmission of that part. So this thing is used for the fiber data distribution interface. If the data transfer interface is not required, it means you never share your data. It means you never share your experiences, you never share your information from other side to other side. So interface play a very pivotal role for the data distribution. So this is one of the most important for the transmission. Now we are talking about some more points about this thing. Computing power levels decibels, because the measurement of dB is for the transmission of the data. The major part, now we are talking about the major part of system design involves keeping an account of optical power along the communication links. Definitely, if I'm connect a network, I show it here. If I can connect a network, look at this. These are 4 different nodes, and here is your network. That network connected this node, connected this node. They are connected to each other. Both way communication is required, and two-way communication is required. They connect this either this way also. So this is a network where all the possibility of sharing of a data. It is not a one-way communication, it is a multi-way communication. The data either may be from the source, either may be from destination. That is depend up to you how you can share your data and how effectively you can understand your data. With that data is to be going from this side, I capture the data from this side and I attempt the data and collaborate with the data with the help of this network. Here, major part of the designing. Important is designing. If designing, you understand. If you're designing, you're getting the point of a designing, it means you understand how the optical power involving on that thing and how how the communication links play a pivotal role. If these nodes are not connected effectively, your data is never shared from one side to the other side. You must be know that your data is to be shared when the nodes are connected electronically or optically, then the data will be shared. If not connected, it means you never share your data effectively and efficiently. So that is an important part of optical communication, and understanding how the optical power is along with communication links is important duration of a transmission from one side to the other side. This is not connected, you never share your data. Single bits of data will be shared from one side to the other sides. So this thing is to be important. Now we are talking about second one. The count is usually necessary to ensure that the wave incident or the detector has sufficient distance to be correctly recognized. Important. One of the major part and important part of this is to just understand which data, which detector, which part is important for sharing the information. If you understand that thing, it means your detector detect the sufficient amount of data and understand if that data is to be bring on my side, I can capture the data and send from the other sides. So this is important. If you understand this thing, your data is very effectively and correctly recognized and travel from the one side to other sides. Now come to the next point. Other instances, the received power may be even to be large, the receiver, depending upon the requirement. If the receiver is not capable of understanding that thing, or the receiver is not capable to receive the power, if the data is too large, so sometimes the receiver is also faulty. So at that moment, you just remember, if the power level is to be higher, the data is also lost if the receiver is not able to capture the data. So this is also an important part of that thing. So understanding of all the process, understanding of all this data is important during the transmission of that power. If I'm not able to understand that thing, it means your network is not perfectly and effectively work. This network is work when communication and the sources and detector and all the part are effectively and efficiently connecting together. If they are connecting together, data is shared. Any amount of data, larger, smaller, bigger, is travel from one side. If you understand that things. If you are not getting the things, your data is never travel. That's why receiver, transmitter, both are very, very important during a transmission. If you know what kind of a data I am sending and you understand what kind of a data I am receiving, it means the data balance between both the things are effectively, efficiently, perfectly used on that. Now, the designer must be certain that does not occur. Always a designer, the main architecture. If I design something, if I design a network, I know everything. The design of my network is very effective, but the design of my network is very efficient. My network is able to share the data. If my network is not able to share the data, it means you are not capable, you are not able to share your data at that duration of the transmission. The role of architecture is very important. So network, whenever you design a network, it is one of the major part in optical communication. Whenever the network is designed, you know what nodes, how many user, how many amount of data, how large the signal, how large the capacity of the signal is to be used during the transmission of that data is important to understand by the user as well as the maintainer which is maintain the data. So these are the important things during the transmission and understanding if the data is perfectly shared from one side to other side or not. If the data is perfectly shared, it means you know the everything about the network and you know the capacity of the network perfectly. So that's why this is very important network for the transmission. Now we are talking about some more things about this decibel calculator. How we calculate the powers. If I'm sending an information from one side to the other side, understanding of the power is very important. If I'm not capable to understand how much amount of data I can share from the one side to other side, it means we are totally wasted of that network, totally wasted of those resources, totally wasted of all the powers which can be used to travel from the one side to other side. So that's an important part. You understand how effectively and how perfectly you share your data. Important thing is to understand the meaning about that part. First thing, if the power P1 is what at one point P1 is the input power, the system P2 is the power of the some other point which is to be traveling from the one side to the other side. Some point further along the link, that P2 by P1 is the fraction of power transmitted between the two locations. I'm talking about two locations. Location means, look at this source. This is the one location where all the information to be gathered and clubbed together, and then now the source is able to transfer. Where? The destination. This is the destination where the data will be sent effectively and efficiently. How we can send? With the help of this. What is this? This is an optical fiber. That is backbone between this and this network. If we know the things, is source, effectively attach all the location, attach all the data, knowing the location of one source to the other source, it means you can just club together and share your data. If you know source is different and destination is different, and the sources are going to beyond the things, you never share your data. This is share when you know which data you want to share, which amount, how much you can share your data, how efficiently, how perfectly you share your data. If you know, then this formula or this calculation is useful for you. Now, the formula is 10 dB is a 10 loop, base 10, P2 upon P1. P2 is the second power sources and P1 is the first power sources. Or it is a point where the power is coming to wattage and we can be clubbed together and share how much data is to be going from one side. Look at this. P2 is P1, 10 dB per dB. That is a point 1, that is a point 2. 3N is a point 4. In between that network is to be consist and connect together and share your data. Without any delay, you can share larger amount of data. You never need, you never explain, you never expose anything about that part. You just understand these are the two things which are used. One is a point 1, work as a source. A point 2, work as for a destination. Then the data will be shared with the help of this optical fiber. And you just find out how much power you can find, how much power you can send, how much data you can travel from the one side to the other side. There is never any lag in between this. So, this point 2 to point 3, point 3 to point 4 and many points. So on is going on. So, in this, you can find out n number of data. You just travel from one side to the other side. Understand how effectively that data is shared from one side to the other side. So, this is the calculation of the power between the one source to the other destination. With the help of this method, or with the help of this formula, you can find out any amount of data. Are you getting my point? Now, go to the next one, part of this one. Look at this. This is the further explanation of the points one by one. 1, 2, 3, 4. How we can find out? How can we check how much amount of data will be travel and transfer from one side to the other side? With the help of this formula, you can share any amount of data. You can find out any point of a data which can be used from the 1 point, 2 point, 3 point, and n number of points. With the help of this formula, just understand how much amount of a power you can share and how much of data will be shared by you. You can efficiently understanding. You can share your views. You can share your data n number of times you can share. But before sharing, you just know the network. You just know the interface, and you know how effectively it is used by us. Getting my point? Now, this is the formula. Previous slide we will be explore. Here the number of sources. Look at this. P4 to P1. How much? P4 by P2. Sorry, P4 by P3. P3 to P2. P2 to P1. If it is P5 and P4 and number of data Pn upon n minus 1, less the data we can be going on to be beyond that part. Just check out huge amount of data, find out how effectively and how perfectly you share the data. At last, just using a logarithmic formation of the data and easily find out from one point to the other point how much amount of data you will share, and it can be captured from the one side to the other sides. No need to worry about it. How the optical data will be shared, how the optical data gather, how the optical data find out with the help of this. You can easily find out. Never never to lose any signal. You never lose any wavelength during the transmission of the signal. This is a very efficient method to find out bigger data transmission. Bigger data transmission. But nowadays, lots of new technology. Sonnet, I'm talking about Sonnet. I'm talking about Manet. I'm talking about ad hoc network. And many other networks. Many other networks will be introduced for transmission of that data. SDH. And many more is used for the transmission of the data. So with the help of this calculation, you can easily find out how effectively and how efficiently you can send your data. So this is important part for the transmission point of view, because whenever you know distribution, whenever you know the network capability, whenever you know how we can club the data, when you know everything about that part, after this is important. You just know how we can calculate, how we can share the information. If you don't understand that thing, it means you lose your information, and you never know how much network is using your information, how much bandwidth is used by the network. But if you know the formula, if you know the calculation, if you know the algorithmic part of this one, yeah, I know how efficiently I can use that thing. This is the beauty about that part. Okay. Now we are going to the next part of this one. Suppose that, now we're talking about the example, some basic part of this. Suppose that I'm using, suppose that the three elements in the previous slide have losses -11, -6.3 dB respectively. Find the total loss of the combination. Find the output power of input value is 5 megawatt. A system has -23 dB of loss. Compute its efficiency. A light emitting diode 2 megawatt. Compute the diverity. And then this is the example of the few things which can be considered used into the optic communications. Because these are the losses we can be find out. These are the things that we can introduce into the system. How we can be find out that? With the help of this we can be using them. Because optical sources, what is that? Light emitting diode. Because optical signal is to be sent by a light emitting diode. So that is the also understanding of point. This signal will be lost during the transmission in the starting point. So this is also understandable point on that part. Now next slide. Nature of light. Now we are talking about nature of light. What kind of a light? Any kind of a light, or maybe something specific light is used for the transmission of that part. That is one of the more major important part of this one. I'm talking this thing. Look at this. Sometimes light behaves as a wave and sometimes as a particle. That's true. It's really true. When the transmission of optical communication, it may work as a wave, like this. Maybe behave like this constantly without any delay and without any stop. That is the simultaneously flowing from the one side to the other side. But sometimes as a particle, it will be flown to the system. That particle is throughout in the optical fiber. Look at this. I'm talking about optical fiber. If I'm talking about an optical fiber, the signal will be flow like that, sometime like that. So that is a depend upon the requirement. Nature of light is to be depend. It is work as a wave or it is work as a particle. That is the beauty about the optical communication. If you understand that part, that is, I'm explaining in further slides. It is a part which can be exploring into a nature, how that nature is defined, how that signal will be transferring from the one side to other side. That thing is to be establishing a network connection between that part. This is the thing which is established a communication part from the optical signal to the from the one part to other parts with the help of this. How? With the nature of that light. We understand that nature of light. Now I am explaining this thing in my next slide. Now look at this. Wave nature of light. I'm talking about the two nature. This is the one type of a nature. I'm taking the one type of a nature that is possible or not possible in this system. The thing is going to be a very efficient, very effectively, and